down. So just try and
okay.
Hopefully it doesn't. But yeah. But you should
Okay,
be
you're in the room.
Yeah.
What's the tech? Just talking to this microphone, is it?
Yeah.
Okay. Right. Okay, thank you very much. Good morning, everybody. Yes, Mark Birkin. I'm Professor of Spatial Analysis and Policy in the School of Geography at the University of Leeds, and also Programme Director for Urban Analytics at the Alan Turing Institute. And I'd like to give you a fairly high-level overview this morning of some of the work that I and others have been involved in the RAMP programme. And I think I can, oops. Just, no. Hang on. Try them all.
So how is this talking to that?
Oh, is it just sticky?
Yeah, it's just.
Okay. Keep trying.
Yeah, you have to press really hard.
Okay, thank you. Okay, well, I think you'll know the background to the RAMP initiative, so I'm going to go straight over that first slide and on to the second one. So in terms of my own involvement, so we had a lot of interesting discussion at the early stages of RAMP about the human behaviour and social aspects of the modelling problem. And so, yeah, this was kind of a formulation that I think was reported in some early minutes action points of the group. So essentially, this is the question that we sought to take a closer look at, and well, you can read for yourselves how exactly it's formulated. But the essence of this, I think, is thinking about how this problem looks if we approach it explicitly from the direction of social interaction and human behaviour, and kind of towards the problem of the pandemic, if you like, rather than the other way around, which, I would think the majority of the activity that we've seen elsewhere has been kind of focused on, okay, we've got a pandemic, how do we build in, the impact of how people move in and out of retail spaces or working environments or those kind of things. So, very much concerned at coming at this from a geographical social science kind of perspective. And, I think another observation I would make about that is, that people on my side of the fence, if you like, probably have a slightly different perspective to those who come from more medical or perhaps even mathematical backgrounds. And so what I would observe, certainly in a lot of the pre-existing models at the start of the pandemic for simulating transmission of diseases and epidemics, is they're often fairly coarse in spatial terms. They may have abstractions that I might not be particularly keen on in relation to my own detailed interests about crude assumptions about the shapes of catchment areas of schools or retail outlets, that kind of thing. Restricted scope in terms of how they're able to cope with real behaviour patterns in the world, especially those that go beyond the core things of work and school. And a bit of context, I've probably spent quite a large portion of my reasonably long career looking at in detail at things like retail and service interaction patterns and trying to understand and model those in a reasonably realistic sort of way. And similarly in relation to demographics, clearly age and sex are represented as very important elements of the mix. But what about other things that might be seen as very important in a modelling and planning context? So here we are. What we actually did at the start of the RAMP initiative was essentially to put together what we thought would be a reasonable process, and then to look for a group of people amongst those who'd volunteered and stepped forward, wanted to contribute here along this kind of structure. Oh dear, I'm not supposed to have that one yet. Oh, well, never mind. It's been a bit of an adventure with the technology this morning. So, yeah, 4 kinds of things. I'm going to talk briefly about these sort of 4 components, but working out again, in a sense, from the kind of spatial microsimulation as a core technique, propensity score matching, building in more behavioral attributes and characteristics of the population, space interaction modeling, how do we move around, and then thinking about how all that factors in and connects to the disease assignment and transmission process. So in essence, we tried to work with a core group in each of those different areas. So some colleagues of mine at the University of Leeds, mostly on the microsimulation side, and then others at Cambridge and Exeter, and on the propensity score matching, the disease transmission element, group from UCL, mostly focused on the space interaction modeling. And then something I might touch on a bit later on, some interesting contributions from the private sector, improbable tech business, mostly operational in the defence sector, but very interested in the social modelling aspect of this. I didn't think about putting any equations in the talk. Actually, I must be too used to talking to geographers and social scientists and people who don't like to see that sort of thing. Yeah, anyway, there's a couple of references to papers and things at the end where there's a bit more technical detail in if anybody wants to look at any of that later on. So, I mean, in terms of microsimulation, spatial microsimulation, which is something that I've also been very interested in for a long time. And so I need to do a bit of kind of visualization here, as it were. But you know, the essence of this microsimulation technique is that we set out to create a synthetic representation of the entire population of the country at quite a high level of spatial and demographic detail. So we're literally talking about having a representation of 60 million people grouped into 25 million or whatever households, and that we can allocate in an extremely representative and realistic way across the whole country. And this is a slightly local example, just to give you an idea. This actually relates to pre-existing work on the Cambridge-Oxford corridor. So you actually see, or the proposed Cambridge-Oxford corridor, you can actually see Cambridge in the northeast of the maps here. So I think the essence of the point I want to make here is you might be slightly surprised that people go to that level of detail in trying to represent the population. You may be slightly skeptical about how effective that is or why people might want to do that. But I think the fact is that a lot of people have spent a long time and substantial academic careers developing, refining, implementing these kinds of techniques. So say, for example, this example is actually looking at a problem of infrastructure investment, the idea of creating a new transport connections, expressways, what have you, between Cambridge and Oxford. How does that associate with housing plans, employment plans? This machine we know has got a life of its own, doesn't it? And so on and so forth. And so creating these microsimulations of the population, factoring in the kinds of activity models, how do people move and operate within labour markets, housing markets in relation to retailing and hospital and services. And all these kinds of questions are fairly well explored by people who live in my world, so to speak. So the second step in this modelling process was, yes, so these models are fairly well developed. Not necessarily, I mean, in any context, part of the challenge is to fine tune to the particular application. Not surprisingly. So one of the core things, the first things, of course, that we needed to do in relation to the pandemic was to think particularly about two more specific aspects of the modelling approach, and as represented in the table on the left-hand side here. So Spencer is the core microsimulation demographic capability. So again, let me emphasize the point that that's quite rich in terms of the way that we represent the population, if I compare to something like just a standard age sex distribution within some other kind of modeling approach. So then we were looking at synthesizing this very rich synthetic data to elements of time use and to health characteristics. And again, as you see in the next piece, time use, of course, is very important if we're thinking about how people are moving around between essentially homework, retail, leisure and school environments, the core locations for transmission. So we want to understand how people are using their time in moving between these different environments, and we want to understand in more detail the health characteristics of these people, which of course is going to affect their susceptibility and so forth. So a couple of sources there: time use survey, health survey for England, and then that can help us to create further additional distributions and insights into the population. So, for example, how in different places time might vary at work or getting to work, variations of the location of key workers and so forth. Oh dear, I haven't quite finished. And the other point I just wanted to note briefly in passing this, okay, it says Devon, you can see here on these screenshots. A lot of the work we did at the initial stages was focused on Devon as a case study. You'll recall perhaps that one of our main contributing groups was in Exeter, who had quite strong connections with the local health organisations and decision makers, policy makers. And so that became a bit of a case study area for us. The model is operational at a national level, and that was always one of our objectives, was to make it universal. But of course, often helpful to have these kind of local examples, and also a bit of local data and that kind of thing. Okay, so in terms of the spatial interaction modelling, and these examples actually relate again to the retailing area specifically. So actually on the left-hand side there, what is being represented are actually locations of data points effectively representing all of the retail centres, retail destinations in the country and their composition. And so what we are looking at on the right-hand side here are the interaction patterns between homes and those retail destinations, in effect. So we are summarising there a series of models which are indicating to us how we can move those synthetic individuals with their very rich characteristics around various retail environments. And I haven't gone into the details here, but as I've said, similar thinking. I mean, this is actually the most developed as it happens, but in relation to commuting patterns and movement into leisure destinations and so forth. Now, in front of this audience, I'm not going to go into any detail on the transmission models here, except to say, many of you will recognize its basic structure in terms of susceptible, exposed, infected, recovered, and so forth. Two things that I think are particularly significant and important about this model. I've tried to pick up at the bottom here. So on the left-hand side, we talk about this kind of hazard allocation model. So quite a key component here is that these individual destinations, whether they're retail locations, workplaces, and so on and so forth, are of course sites for potential transmission. So the way this works is that we have our individuals in the model who acquire infection and become susceptible and so forth. They then move into and out of these individual destinations, which become hazardous locations. The more people are moving, the more infected people are moving in and out of these particular locations, the longer they're staying there, then the greater the risk and the more transmission we get through the model. On the right-hand side there, I just wanted to point to, again, I've indicated that the components of this model are quite rich in terms of their attributes and representation. So, for example, we can take things like looking at the influence of the body mass index of people on their susceptibility or transmission patterns and adopt quite a refined approach here. Okay, so if we're able to do all this, then we can start to think about how can these models get applied in particular scenarios. And of course, this kind of modeling is particularly well suited to scenarios that have a spatial or a social dimension. So particularly thinking about various different elements and approaches to lockdowns. So one of the core approaches that examples that we use to illustrate all this is thinking about the timing of the lockdown. So in the scenario here, we're looking at what we think the impact might have been if we'd been able to lock Devon down a week earlier than was actually the case. Of course, that is extremely favourable, as one might expect, and is of course a little bit thought-provoking in terms of the timing and impact of those kinds of decisions. And again, you think about doing quite a lot of refined things with those kind of scenarios. For example, looking at the various demographic and spatial impacts of those kinds of decisions. One of the things that we invested a fair amount of time in was creating a demonstrator of all this. And again, there's a link later. I think this is still online. If anyone wants to look at it, there is actually an illustration of the model running through. I'm not sure you see particularly clear on that, but there will be some red dots in there somewhere. The white dots are the households. The red dots represent households with in which COVID is present. So we can do the dynamics on how a pandemic might spread through a region or a county. We can see, kind of on the left-hand side here of this kind of prototype decision support system kind of thing. Yeah, how that looks in sort of summary terms, and then importantly, we're also thinking about these various kinds of levers, these scenario interventions that we might think about in terms of closing the schools or restricting access to pubs and restaurants and all that kind of thing. Okay, just a couple more minutes. So. In terms of the features of this model, and I mentioned what I would consider to be some of the limitations of a number of existing models at the start. So we have a very spatially refined approach, middle level super output areas, zones of maybe a couple of thousand people, I think typically. Well, I haven't talked a lot about the kind of calibration, but I indicated all those data points in the retail example, for example. So using quite a lot of real data about places, about mobility patterns, to actually get a feel for real behaviour and movement patterns, ranging from retail, leisure, transport, hospitals, schools, workplaces, and with detailed demographic profiling. So thinking in detail about labour market, workplace composition, and other stuff. I think. I probably would have said some of this at the start anyway, but I hope we've demonstrated to some degree through our work how important behavioural modelling is as a complement to other kinds of epidemiological approach. I think the idea of scenarios, what if simulations and analytics, is very important in thinking about policy response to these kinds of situations. I think the level of granularity that we adopt is potentially very useful, and in common with a lot of good work that's been done in this area, all the stuff developed in open source, but bringing together a team from across disciplines, across places, and with very, very different skills. A couple of negatives very quickly. Reflecting on the RAMP acronym, I'm not sure whether we necessarily provide as much practical assistance as I might have hoped at the start of the process in modelling the pandemic, and the work wasn't as rapid as we might have liked either. But again, I think that's just a representation of how complex these kinds of problems are. A lot of issues around the data. I mentioned we use quite a lot of data. There's quite a lot of other stuff from banks or retailers or mobile telephone operators that I would really have liked to incorporate. And I think it's quite thought-provoking how difficult it was to mobilize some of that, even under the kind of pressure incentive of a pandemic. And then finally, very quickly, so just thinking about the long-term implications, future extensions. The top left there is some local work we were involved with in Leeds that again was interesting, but founded a bit on the ability of people to actually think through quickly enough what kind of interventions might be possible in that sort of context. Maybe I'll leave the bottom because I touched on that already, but this is a really interesting exchange involving Patrick Vallance, Chris Whitty, and the House of Commons Select Committee at the end of 2020, where they're being pressed quite hard on, did we really need to close all the pubs and restaurants? And the MPs really concerned about the impact on the economy and these kind of questions. And Patrick Vallance saying, well, we don't really have any way of thinking about those kind of questions. And I think again that is something that I think it is possible to begin thinking through with this kind of approach. Potentially those balances between the economic ambitions and the public health requirements and so forth. So yeah, I'll leave it there.
Thank you very much. Got time for a couple of questions before the coffee break. Sorry, at the top there, I think you were first. Oh, sorry. Oh.
Hello, yeah. Does that work? Sort of, yes, there we go. Hi, yeah, thank you very much for your talk, very interesting. I was actually just wondering, do you also look at fitting the model to data so that you can understand the impact of, or the relative importance of meeting and mixing in different venues? Or are you sort of doing that some other way and doing these scenarios in a slightly different way?
One of the things I didn't quite get to, I did mention events right on that last slide there. So we got involved in some way. In some work, there was actually a workshop at the Bayes Institute in Edinburgh about a year ago, which involved, they got a number of specific partner organisations involved. I remember Bath Rugby Club being one of them for some reason. Edinburgh Fringe were involved. There were a couple of others. And so we have done a bit of work on looking at particular events. Again, you're kind of building the patterns around those, looking at the impacts of different control strategies of having them or not having them and so forth. Again, your data is a bit of an issue there. It would be great to work with, I don't know, Whitbread, Costa, specific organisations who are actually responsible for representatives. Again, that was the idea of working with people like Bath Rugby. But certainly in principle, one can do a lot. In practice, there's a lot to be done, if you see what I mean.
Okay.
I'll come to
One of the criticisms of the traditional differential equation-based model like SIR is that it makes unrealistic assumptions about social mixing, universal mixing assumptions. And part of the promise of a more spatially explicit model like this is that it gets to reduce the absurdity of the universal mixing assumption. Did you try comparing an epidemic with your model against a differential equation model to find out what kind of differences were you finding in its behavior?
We didn't. I think that would be a very interesting thing to do. I agree with you about the mixing, and yeah, again, I'm not talked about it in detail, but yeah, I talked about the microsimulation. Then, when we're thinking about these kind of mobility patterns, they are largely being, well, actually, and particularly the kind of the hazard part of the modelling is essentially being driven by something like an agent-based model. So you have those agent-type assumptions. Yeah, I think adding kind of social mixing explicitly, so particularly within and between households into that kind of framework, is something that is conceptually it can be done. I think again, it's an area where one of the difficulties is the data is still not that great at the moment. You see a lot of papers where people are essentially using things like Twitter or Facebook as proxies for social interaction, and it's almost the reverse. You know what I mean? So again, I think there's a lot of potential there. That's certainly the sort of thing we're interested in. But yeah, I'm conscious of the thinker in the previous presentation. There's so many different directions that one wanted to go in simultaneously with this work, but we didn't get onto all of it, unfortunately.
Thank you. We've got a final question at the back from.
Hi there. I think it's sort of following on from that question. I mean, with these sort of models, it's the validation could be quite tricky. And how, after 2.5 years, how do you think these sort of models are useful for the next pandemic, and what needs to be done to make them the model for the next pandemic?
Yeah, so I completely agree about the validation. Again, I didn't dwell on it. One of the reasons why I say we work particularly closely with Exeter and with Devon is because we were able to do some validation on those baseline kind of transmission patterns, which is hugely problematic, but let's not get into that. I mean, I think there are things that we can do. Again, one of the illustrations on my last slide that I didn't talk about in the interest of time, but one of the ways that we are currently using these models is there's a lot of work going on about people with the national transport digital twin. And one of the interesting things about that is it has a very obvious kind of real-time component, because we have these sort of sensor type technologies where we can look in very close to real time at what's going on on roads and rail networks and bus networks and all this kind of thing. And that offers really interesting capability for validation, because you can actually see, tell me how many cars are going to go past that window in the next 10 minutes or what have you. Now, I mean, knitting all that together in terms of how does that help us to create, be more resilient for a future pandemic is a big challenge. I mean, I think it can be done, or progress can be made. But yeah, everyone in this room is probably thinking the same thing, right, in relation to their field. We need a bit of investment, and concentrated effort to actually allow us to do that. And if we just carry on until the next one comes along, then we'll be running around facing variants of the same problems, I'm sure.
Sorry, thanks. Sorry, we're just discussing the coffee plans. Thank you very much again, Mark.